So, hello everybody. Our project is called Elevator Management System, and this project is prepared by me, Dostan Bektilev, from section 002, and Shohrukh Rustam, section 001. So, our presentation consists of 3 parts: introduction. This section defines problem statement, solution, which is proposed by our side, and analysis of our approach. So let's dive into intro. Here we'll discuss how elevators manage the operation, advantages of modern elevators compared to old ones. So elevators, which we daily use, best tool to move up and down in tall buildings, skyscrapers. It's especially convenient for elderly people, and it should be fast and comfort. So operations included in elevators are picking passengers in one direction until elevator is empty. This means picking passenger is insertion to data structure, container. And at the time of insertion, it should be automatically sorted, which we will discuss later. So change the direction based on the request once it's empty. Okay, we will see this one also. Transporting passengers to their selected floors. That means after serving for one client, that request should be deleted from data structure. This is how, this is the logic how elevators should work. Okay, choice of data structure. Let's say we choose array. If we choose array, it would be problem when deleting or inserting element, because if we delete from array, there is a memory shift, so it's not good. And insertion from the beginning or in between some nodes require ON time complexity, and there is memory shifting there. If we use stack, we are only allowed to work with just top value of our data structure. If we use queue, we are only allowed to insert or delete only from the edges, but we don't want this. So we'll use linked list based on stack approach. Some parts are taken from stack data structure, because insertion and deletion takes O1 time complexity and allows such operations throughout the list, not only from the beginning or from the end. Why linked list? Our application requires insertion and deletion throughout the list without losing the order of elements. Firstly, to avoid sorting, as it requires higher time complexity, like n square, or so that we can keep the order of elements by inserting in between 2 other elements. Like if we want to insert 4 in our linked list, we should insert it after 3, before 5. In this order, we can keep our data sorted. So the node is deleted only from beginning, as we keep the request to be served first as head of linked list. So its runtime complexity is O1. So the request which should be served first is kept as the head of our linked list. So deletion takes O1 time complexity. Okay, choice of algorithm. Here you can see linked list class, request class, lift class, and you can see add request method of lift class. Okay, in our linked list, we only keep first element of our linked list to find like starting point of list. So in our request class, request is a node of linked list. So we have starting point of that request. Where the client, where the user is right now. where he wants to stop and in which to which direction he wants to move, and the next request. So these are to keep our data. So in our lift class, we have direction of the lift and current flow, which is lift now. So we have two linked lists in order to store requests down and requests up. So let's analyze our add request function. Okay, this is only one case. There are typically much more cases which should be taken account. So if we assume that our request, our user wants to go up, and our elevator is also, our elevator's direction is also up, how do we know the priority? I mean, which client should be served first? If we now, let's see this process in code. Just a minute. Okay. Let's run our code. So here you can see 6 options. Show where is elevator. Let's see. It says that our elevator is now at first floor. Let's see the direction. Direction is up. So if we insert 5, you can see that empty list show requests to up. So we don't have requests to up, and so down also. Let's now add request, enter current flow. So the elevator is on first floor. Let's say we want to go to, we are now at 4th floor and want to go to 7th floor. Okay, if we now see all the requests, we have 4 and 7 in our request to up linked list. So let's add another one, add request. So let's say we are now at 5th floor, no, at 3rd floor, let's say, and we want to go to 9th floor. So, and let's see how many. We have 3, 4, 7, 9. You can see the order is maintained. Let's now move our elevator. Okay. We moved our elevator, and let's see the location of elevator right now. It's at 2nd. Let's move it once more. Let's see where it is. It's at 3rd floor. Now let's see where our requests up. 4, 7, 9. The 3 disappeared, as client which stood at 3rd floor is already in our elevator. So let's move fastly. And which floor? We are now at 7th floor. Let's see now requests up list. We only got 9. So let's move twice more. And now you can see our position is at 9th floor, and we can say that our requests up is empty now. Yeah, that's right. So our direction is to up. Okay, let's now to add request to down. Okay, we are now at 9th floor, and we want to go to 5th floor. Now you can see that our request to down, we have 9 and 5 in descending order, because user at highest floor is served to be first, and it acts like this, it works like this. Okay. The choice of algorithm we discussed already, and limitations of future scope. Okay, this scheduling algorithm is non-primitive, which means that the process can't be stopped in middle of execution. We must wait the the finish of the program. And it may take so long time if there are requests in the same direction of an elevator, even if you requested firstly. Let's say elevator is now at 10th floor and you are at third floor and you want to go down. So when you press call button to bottom, the signal goes to elevator and elevator starts to move towards you, downward. But in the middle of third and 10th floor, there may be another calls, and the calls can be directed to downward, and in between there will be there is a possibility when more users want to go downward, for example, from 9th to 7th, from 6 to 4, so that, and you should wait all of them until the elevator comes to your current floor. So these are limitations, and also it would be better if one more reset button is added. What's the function of reset button? If waiting time is very long and your time is limited, you just ignore the elevator and go through stairs. And in this situation, you should cancel in order to save others time. And in future, we also want to add this functionality. So thank you for your attention. That's all from our side.